Good morning, students. In the last section, we discussed the conical pendulum, its time period and frequency. In today's lecture, we are going to learn vertical circular motion. What is vertical circular motion? When a metal bob is attached to a massless string and it is rotated in a vertical circle, then we can say that the bob is performing vertical circular motion. As the bob is rotating in a vertical circular motion, the effect of gravity at the lowest position, at the middle position, and at the topmost position will be different, and therefore the velocity at each position also will be different. Therefore, in this section we are going to determine the tension of the string at point A, B and C. Point A is the uppermost point, point B is the middle point, and this point C, it is the lowermost point. Therefore, in this section we are going to determine the tension in the string when it is at the uppermost position, middle position and the lower position. Consider a metal ball of mass m. It is rotating in a vertical circle of radius r. Now it is a circular motion, and for circular motion there will be a centripetal force. So while performing the circular motion, the velocity at each point will be different. Consider the velocity at point A is equal to Va, the velocity at point B is equal to Vb, and the velocity at point C is equal to Vc. From this diagram, we can set the equation according to the balancing condition. How? When the string is at the position A, then we can say that the weight of the object or the weight of the bob is in the downward direction. Similarly, the tension in the string is also in the downward direction. Therefore, the resultant of this tension and this weight of the body in the centripetal force. Therefore, in this case, we can write the tension in the string at point A plus the weight of the body mg is equal to, it is equal to centripetal force. And what is the centripetal force? It is equal to mva square divided by r. Now, while performing this circular motion at point B, what happened at point B? The velocity at point B is equal to Vb, which is tangential to the circular motion. Now, here only a tension is acting on this string towards the rigid support, that is equal to O. Therefore, we can write this equation as Tb is equal to, what is Tb is equal to? It is equal to the centripetal force. Again, it is equal to mvb square divided by r. Then this metal bob is come to the position C, which is the lowermost position. Let the velocity is equal to Vc. In this case, the weight of the object is acting in the downward direction and the tension in the string is acting in the upward direction. Therefore, in this case, we can write this tension Tc minus mg is equal to, it is equal to again the centripetal force, which is equal to mvc square divided by r. Therefore, in this way, we can determine the tension in the string at point A, B and C. From these three equation, it is clear that the tension in the string at the uppermost position is less, and in the downward position, in the lower position, it is equal to less. Therefore, if we have to calculate the velocity at point A, B and C respectively, then by using these three equations, we can easily calculate the velocity at three different points. How? Consider that the metal bob is only to complete one revolution. When it completes only one revolution, as the metal bob go from lower position to the higher position, then this string gets slack and the tension in the stream becomes equal to 0. Therefore, to find out the velocity at point A, in this equation we keep this tension at point A is equal to 0. Therefore, we can write it is equal to mg is equal to mva square divided by r. This get cancelled. Therefore, we can write here va is equal to under root of rg. This is the velocity at the uppermost point. Then, if you have to calculate the velocity at point B, then we are considering the law of conservation of energy, which state that the total energy at any point in the circular motion will be constant. Therefore, by using this law of conservation of energy, we can determine the velocity at point B. Therefore, to find the velocity at point B, we can write this total energy at point B must be equal to the total energy at point A. What is total energy? Total energy is the sum of kinetic energy and potential energy. Therefore, here we can write kinetic energy at point B plus potential energy at point B, which is equal to again kinetic energy at point A plus potential energy at point A. Now, what is the kinetic energy at point B? We know kinetic energy is equal to 1 half mv square. Here it is equal to vb square plus potential energy at point B. What is the potential energy at point B? This point B is at a distance r from this lowermost position. Therefore, we can write the potential energy is equal to mg h, which is equal to r. Now, kinetic energy at point A. What is the kinetic energy at point A? It is equal to 1 half m va square plus potential energy at point A. The potential energy at point A can be calculated by considering that this point A is at a distance twice r. This r and r twice r from this lowermost position. Therefore, we can write it is equal to mg into 2r. Therefore, it is 1 by 2 m vb square plus mgr equal to 1 by 2 m va square. What is va is equal to under root rg. Therefore, va square is equal to only rg. Therefore, it is equal to mrg plus twice mgr. Therefore, we can write here it is 1 by 2 m vb square plus, or it is equal to, it is 1 by 2 mgr plus twice mgr and minus mgr. If we take common m from these three equations, then this m and this m get cancelled. We can write here it is equal to 1 by 2 vb square. It is equal to 1 by 2 gr and 2 mgr minus 1 mgr equal to mgr. We can write here it is equal to gr. So what is equal to? It is equal to 3 by 2 gr. It is equal to 1 by 2 vb square. Now, 1 by 2 1 by 2 cancel. Therefore, we can write here vb square is equal to 3 by 3 gr. Therefore, this vb is equal to under root 3 gr or 3rg. This is the velocity of the metal bomb at the middle position B. Now, similarly, we can calculate the velocity at point C by using conservation of energy, and by using this conservation of energy, the velocity at point C, BC, is come out to be under root 5 rg. Therefore, from these three equations VA, VB and VC, it is clear that the velocity of a particle performing vertical circular motion is less at the topmost position. As it goes in the downward direction, the velocity goes on increasing, and as it comes to the lowermost position, its velocity increases. Therefore, we can say that in the vertical circular motion, the velocity of the particle get changes. If it is come in the downward direction, it increases. If it going in the upward direction, the velocity decreases. Today, we are going to stop here. In the next section, we are going to determine the another topic. Thank you.